Okay, yeah. So before we start the talk is about me like enjoying this new API. So there's gonna be like a few small technical background about what this API is, but mostly they're gonna be experiments. So the idea is how we can combine this API with existing HTML5 API and get some weird, interesting, fun, maybe useless but fun results. I have a drone. Hopefully it will fly. There is a lamp here, which I don't know if everyone can see it. It's just here. I can try to move it, but yeah, maybe like this. It's better. So it's a smart light. It can like be turned off and on via Bluetooth. So we're gonna do some connections. Okay. 4 more minutes. Yeah, I started getting into this technology because I was looking for some smart light for my house, and the Philips one were too expensive. So I found this one. This is I didn't know the brand before. It's called Ovox, and those are sold for like 20 euros each, which is pretty cheap for a smart light. And instead of being Wi-Fi enabled, they are Bluetooth enabled. So once I bought the smart light, a friend of mine gifted me with Alexa, the Amazon Echo. Okay. So the first task was, and Alexa works on Wi-Fi and so only on some specific device. So the first task was to make Alexa work with my light I bought. And to do that, I used Raspberry API, but I found out that it's actually a Bluetooth low energy device. At that point, I found out about Web Bluetooth API, and I started digging into how we can drive the light with the with my laptop, and this is how everything started. So, and from there, then I discovered that you can like do there are like a huge amount of Bluetooth low energy device around, and all of them are broadcasting their services, most of them. So it's just fun to go out, discover those devices, and try to interact with those services. Some of them are standard, so they are very easy to discover. Some of them are less standard, but they can be discovered anyway. And there's a huge community of people trying to do that, so you can always look for help. Okay, 2 more minutes. Actually, you can't hide the mouse. I'm gonna move it like in the lowest corner possible. Okay. I'm sorry. I know it's gonna be a 4-star presentation just for this, so yeah. Yeah, it's still there, but maybe you can't see it. Unfortunately, no, not this time. There is some interaction with the speech though, so hopefully we'll be able to do something with the speech recognition. Hopefully. So this talk is packed with demo. Some will work, some may not. Finger crossed. Yeah, I can start. Okay, so again, this is a talk about Web Bluetooth. It's a talk about how we can use Web Bluetooth and how Web Bluetooth works and how we can interact, make Web Bluetooth interact with other HTML5 technologies. This should work. Yay! So I'd like to start with a demo, just to like hope everything will work. On the chair, you can see a smart light. It's basically just a bulb, but it has Bluetooth capabilities. So what I will try to do now is to okay, there's a small activate button here. So the way this is just to show how the Web Bluetooth API works, hopefully. So when you click the activate button, a browser window pop up. This browser window doesn't show all the Bluetooth device around. It just shows the one that you're looking for. So we'll see later. You have to specify a kind of filter and some services you want to look for in those devices. Now what we can do is we can choose the light. If I can click correctly. Can you just click, please? It is? Maybe? Let's see. Yeah, no, it's not. I can try again. Okay, activate. Yay. The thing I can't select this, it's slightly annoying. Yeah, but it's not really. um, it has to actually select the device. I don't know. This is new. Maybe it's just taking longer. I have videos of all the demos because I thought something might happen, but yeah, that's annoying. Let's try one more time and then we can pass to the video. Okay. Sample 1, light. Please find the light. Let's do this. Maybe Bluetooth is not working for whatever reason. So what if we turn this down and then turn it off again? And then we cancel this and then we reload. Maybe we can try. I don't know. It's just weird. In the meanwhile, open for the next demo to work. Otherwise, it's going to be a pretty boring talk. So how this thing is supposed to work? Yeah. So activate. This is the light. The Bluetooth selection pop up. What you can do, you can look at Mario Bros. What you can do is you can select the device you want to connect with, and after you've done that, you can basically interact with the services. So you can turn it off, you can turn it on, and you can, in this case specifically, since it's a smart light, you can control the colors. So you can switch the colors to any tonality, and the light will adjust. So in this case, it's kind of bluish. Or you can change it to like red or something. Okay. We'll hopefully have more chance to test this in a more meaningful way, but for now, let's continue. Okie doke. So how does Bluetooth, how does the interaction with the Bluetooth system work? So every Bluetooth device is divided into like a hierarchy. And this hierarchy is split between services, that's the highest level, and then characteristics. So the idea is, if you want to connect to a Bluetooth device using the browser, you have to specify which services you want to connect with, right, the device first, and then the services you want to connect with, and then the characteristics you want to connect with. So you have to go through all this kind of tree. The way it works, it's kind of verbose, and it looks like this. So you have like the first step is navigator.bluetooth.requestDevice, and what it does, it allows you to specify how you want to identify the device you want to connect with. So in this specific case, you can specify some services you expect to find on the device. Another thing you can do is you can specify a part of the name of the device. So the device, when it's connected, it broadcasts the name, and you can search for matching a part of that name. Once you got the device, you need to connect to the device, and this is pretty straightforward. Then you have to get the service, so ask for a specific service, ask for a specific characteristic, and then finally, when you are connected to the characteristic, you can either decide to read a value or write a value. In this case, this is the smart light, so what we want to do is actually read the value and then just print if the value is on and off. most of the, like all the devices I've worked with, they always return byte array, so you have to use typed, I mean, they always return typed array in the JavaScript world. So then you have to invoke this like get your int 8 or whatever and get the desired bit of that array. In this case, it's simply 1 or 0, 1 for on and 2 for off. There are a few annoyances. Before we continue, we have to, remember. The first of all, like, demos may not work. That's on me. The API is not standard yet. So it's a draft proposal. It's it has been proposed by Google. It's under consideration by other browsers, but it's not there yet. There is a very similar API on Firefox OS, so we expect Firefox to kind of converge at some point, but yeah, it's Chrome only. Good news, it means it's Android. So on mobile, you have a huge amount of devices that can actually support this API, which is pretty good. There's no discovery. What does it mean? It means that there's no way, as of now, or using the Bluetooth API to have such information like how many devices are around that support that specific characteristic. You can't do this kind of scanning. It's always the browser doing that for you. So the user has always to pick one device manually, and then you get connected to that device. There's no way to actually scan this room and say how many are exposing the, I don't know, battery service. It's yet, since Google is actually defining the API, but yeah, so nothing for now. Only passive, so Bluetooth LTA can be passive or active, so it can be actually, you can actually like read a Bluetooth device, so you can actually, like be the reader, like be an active device. In this case, the Bluetooth API can only connect to passive devices, so this is kind of a limitation. That's kind of tricky one. So there's no way to instantiate a connection without a direct user action. So for example, a thing you can't do is when the application starts, do the connection. You can't, it will fail. The promise will fail. The reason is there needs always to be a user interaction in order to instantiate a Bluetooth connection. So you have to have a button click and something like that. You have to handle drop connection, so connection can drop. And you always have a flag. We'll see it later. There's always a flag on the connection on the server, on the Bluetooth server, and you can use that flag to detect if the server is connected or not. And if not, you have to redo the connection. You can't perform two writing contemporarily, which is pretty. I mean, it's pretty obvious, but it means that you have to take care that a write can fail if there's another write going on. So you have to actually measure and take care of that. And another issue is you can't do a connection if there's another connection in progress. So those are small annoyances, but altogether it means that making a Bluetooth Bluetooth-powered kind of application, it's yeah, annoying. The last one bit is the one we discussed before. So we have like a huge amount of services. Like there are like a lot, really like a huge amount of low-energy Bluetooth-powered device. Like I didn't know, but my TV had a Bluetooth service. The point is, some of them are public and standard. So there's actually like a string that specify the service, and you can use that string to reach the service. An example is like if you have a Fitbit or any like sport bracelet, they're gonna expose probably mostly standard services like health rate. Or some devices expose battery status. Those are actually public devices. Sorry, public services. But most of them, like this light and the drone and a lot of other stuff, do not have this feature. So all those services are private, which means private. It means that they're not kind of standardized. So they are basically just identified by UID. Which makes things a little more tricky because when you inspect one of those devices, you end up having just a list of UIDs and you don't know what they will do. So you have either to rely on the community or do it yourself and start, playing with those services and see what happens, which is what I did with this light. Yeah, this is the support table. Yeah, it's sad. Also, if you notice, I'm using a Chromebook. The Chromebook has been the first Chrome enabled. It's been the first having like a web Bluetooth because of like it's Chrome OS, so it's super easy to enable stuff on top of Chromebook for Chrome. Now also the Chrome on Mac support web Bluetooth. There's no support on Chrome on Windows. So if you have a Windows laptop, you can't use web Bluetooth even if you have Chrome. And the good news is down there with Chrome for Android. That's a good news. It means most of the modern devices has web Bluetooth, which is great. And then yes, we have Opera, but that's okay. Okay, so to try to kind of improve a little the way we work with web Bluetooth, I wrote a small library. It's just syntactic sugar, so it doesn't do anything like magic. It just removes some of the annoyances we had with the code we saw before, like reconnection, having parallel writing going on, having parallel collection going on, caching, like this thing does cache services, cache characteristics. So it's just a syntactic layer, but it makes working with web Bluetooth slightly easier than having to do like this promise tree you saw before. So the way it works, it's kind of straightforward. You instantiate a new device, and then you register a pair of service and characteristics. So you can do like in this case, I want to use the light characteristic on the light service, so I just register those two informations, and I get back a function. At that point, what I can do is just invoking the function. The function always returns a promise. But if I invoke the function without any parameter, that means read. If I invoke the function with one parameter, that means write. So it's just a way to compress all the all this kind of huge tree, and to have some caching in between, and to have the reconnection. So the library was supposed to be out, but I haven't published yet. I'm finishing like README, all the stuff. It's gonna be out like today-ish. No, tomorrow. Today it's kind of tomorrow. Okay, so armed with this information and armed with this new library, which will make our life a little easier, we can start exploring, like hopefully some nice interactions between web Bluetooth and other HTML5 APIs, which is the point of the whole talk. So the first thing is, what if we use web Bluetooth with WebRTC? The idea is WebRTC, specifically a subset of the API in WebRTC, which are the get user media API. They allow you to interact with the camera, right? So you can have a stream coming from the camera, and what if we use that stream to somehow drive the light? So for example, we can build a camera color picker, where we could use your camera, like in this case the desktop camera, but more probably like the phone camera, to actually like look at something and pick the dominant color. This is not gonna work, but I have a video. Okay, now let's try first. Okay. So this is how it was supposed to work, which, yeah, it's not ideal, but yeah. So experiment, start experiment, you see the light, you click on it, you pair. And what now happens is that now the camera is actually a color picker. So in this case, this is a blue notebook, and you can see the camera, the light reacting to the object. Now I'm loading. Now I'm kind of picking a red kind of glass cleaner. Glasses cleaner, which is this. And when you move it closer to the camera, the light is actually reacting again. So this is kind of I'm pretty sure this thing will restart working just after the presentation. So if you want to stay for lunch, we can try all these things together. Yeah, it's amazing. Okay, fair enough. Okay, so how does this thing work? There's a camera. The camera. What you can do with the camera is ask for the browser to give you a stream from the camera. So what we do here is we take the stream from the camera, we move this stream into a video element, and then we use a canvas to take all these pixels from the video element, and then we analyze them. We take the dominant color, and then we fire the dominant color to the Bluetooth device. I just want to show you like a small chunk of the code. This is not the whole thing, but it's the most important bits. So on top, you can see how we can like register to the device, and we register our services like you did before with the library. So in color now, you have a function that returns a promise that allows you to read or write on the color characteristic on the light. Once we do that, we can use the getUserMedia API, like the thing in the middle, to get a video stream. So at that point, we have a video stream. A video stream is actually associated to a video object, like an HTML5 video object. And at that point, you actually, you know, if you want to display this video object, you will see the actual video going on the screen. But we don't want to do that. What we want to do is we want to use a canvas, especially like this draw image function, to draw the video on a canvas. Why we want to do that? Because the canvas has this very, very cool property of being able to read the pixel of the stuff we draw on it. So once we draw the video, we basically have a snapshot from the video available on the canvas to be read. So at that point, what we can do is we can use the function getImageData to extract all the pixels from the canvas. And at this point, we have just a list of like a huge list of pixels. Once we've done that, there are like a lot of libraries. In this case, the one I use is called ColorTiff. And what this library does is, given this array of pixels, it returns you the dominant color. So at that point, we have the dominant color, and with the dominant color, we can invoke the Bluetooth function to change the dominant color in the light, which I was supposed to show, but yeah, fair enough. Okay, so again, everything started with Alexa, at least for me, for my experimentation, and after like a month ago, or like a few weeks ago, there was a speech about the web speech API, which are awesome because they are not standard, they are not that much supported, but they are really good to do speech to text and text to speech translations. They basically rely on a remote server to basically take the input from the audio and translate it into words. These are only supported in Chrome right now, which is, again, like not ideal, but they works really well. So my idea was why we can't combine two things and actually have our own Alexa, right? So you go to a website and then you basically can control the light. The use case for this would be like, let's suppose you go in a hotel and instead of like having to download the hotel app or doing something like that and nobody does, you can go to a website and control like the room without having to download anything. I'm gonna try, but I'm really pessimistic now. But it is not working. I don't know why. Let me. Yeah, I maybe it's the full screen thingy, which would be crazy. Here it works. Let me bring it back there. So now it's paired. At least one. Okay, now it's paired. You see? Okay, so. Off. On. Well, off is enough. On. Yeah. Okay, not too bad. 50% out. Let's try again. On. Anyway, it can turn on. Let's continue. I don't want to waste too much of your time. At least something worked, which is nice. So how this thing is supposed to work, this is easier from like a technical perspective. We have the web speech recognition API. Those API, what they do is basically start listening. It's also amazing because they start listening to your like voice without asking for any permission, which is weird, but yeah. So so they start listening to your voice, and they can basically send you chunk of text as soon as they recognize them. So you will get basically an event, we'll see in a second, every time the voice recognition, the web speech API basically get a chunk of text from your voice. So you get an event. In this case, what we're looking for is just 2 words, on and off, within those strings. And then it's the same thing as before. So we just forward those information to the Bluetooth. Okie doke. So how this thing works? The code is slightly smaller than before. It begins the same way. You have a device, you register some services, and what you do then is you invoke the speech recognition, the WebKit speech recognition service, which it's still prefixed, so yeah, it's kind of, not standard yet. The interesting bit is you use the continuous flag to basically you want the speech recognition service to notify you as soon as a chunk is ready. You don't want to wait for the whole kind of phrase to be translated, and then you listen to the button, which is the button, the start experiment button. When the button is clicked, what we do is we invoke the toggle function, so we turn on the light to start in a kind of in a consistent state, and then we start the recognition. Now the recognition API works like any other event emitter object. So they have their own event called result. So what we need to do is basically just listen to that event, and within that event, this event is invoked every time a new token is available. So it's invoked pretty frequently. So what we need to do is inside this event, we have all the results. We can look for the most recent one and just compare it to the string we are looking for. So it's very rough in a sense. It can be improved, but this is kind of the core functionality we are looking at. Okie doke. Okay. Next step. So there are scenarios where you don't want to like write stuff. You want to read stuff from a device. If you think about a heart rate monitor, or if you think about like a battery level, those information are not information you want to write, are information you want to read from. And specifically, those information that can change. So the problem about this would be like having to poll a device continuously to have those information this information in the most updated version possible, which is kind of annoying, and polling is not really healthy for the device. So we have something called the notifications. What the notification does, those are part of the API, and they allow you to subscribe to changes inside specific characteristic inside the device. So you can basically ask the device to notify the browser every time something changes in that specific characteristic. For this demo, which I will really hope it works, I'm gonna emulate a Bluetooth low energy device using this phone. And there is a very, very nice application called Bluetooth Peripheral Emulator from Google that basically allow you to emulate services like a battery status. So what we are going to do is we are going to showcase the battery status on the browser. And we're going to change it in the real time and see it change. This is kind of the intent. Let's see. Okay, so given that now it works, I'm going to bring it down, move it to the screen. Yeah, no luck. Maybe it's too noisy. Which is weird. Oh, wait. Okay. Yeah. Okay. I can show you anyway. I have like life-saving video. Um, so the way this thing works is like this. Come on, video at least. Okay. Uh, okay. So we have the battery service, and the way it works is again you can connect to the device, and it's pretty straightforward really. So what it happens is that the device is now instructed to send notifications to the browser. So it's kind of changed the way. Now it becomes a push thing. So every time you change the battery level, uh, the browser can be notified about this change and react accordingly. Now I'm struggling to drag this thing. It's gonna take like a few more seconds. Okay, yeah. And yeah, so this is kind of the result. But again, we're gonna run all the demos after the talk, like in a smaller room. Um, so the way this thing works is, again, pretty easy. As soon as you get the characteristic, what you need to do is you need to um, ask for notifications to be sent to you uh, from that specific characteristic. So this is kind of an intentional request you have to make only to that specific characteristic. And after you do that, this thing returns a promise. And when the promise is resolved, then basically the characteristic is now an event emitter. So you can listen to a specific event in this, which is called long name characteristic value changed. And this works like as an every event handler. So the function is called every time you get a new value from that specific characteristic. If you want to stop this process, you can use the stop notification function, and then you can remove the event listener. This is the demo itself, and there is a small difference here, which is interesting, is that in this case the services are not UID, they are like proper strings, and this is how it works for services and characteristic when they are standard. So you don't have to look for the UID, you can just specify the string straight away, and that works out of the box, which is nice. Then we have the usual button to start the experiment. When the button starts, when the user click the button, we extract the characteristic from our library. So we get back the characteristic, and then we basically implement the code you saw before. So we ask the characteristic to notify us every time a new value is available, and then we add the event listener. What the event listener does is simply updating the progress bar based on the new value. Okay. Yeah. So this is gonna be either fun or not working. I don't have a video for this, so yeah, short story behind this demo. I found this thing online. I was like totally immersed with the light and smart light and things like that when I noticed someone like did better, and we have to thank this Nessie user on GitHub who basically took another demo from Voodoo Tiki God and translate it into web Bluetooth. What this demo does is actually connection to the popular brand of drones called Parrot drones and allow to drive them. So basically, the user did like a huge work of research trying to do reverse engineering on those drones, reading all the services, and try to see how they work. So I have two demos. One is the original one, the one taken from the post-how repository. And the second one is the one I adapted, and I'm gonna to convert it to basically port it for JSGAT, which is the library I wrote. Now, let's see if those works, which I think they're not. But again, if you're interested, we can like continue after the talk. So I'm hopefully not gonna kill any of you. Sorry, I just don't want to. Okay, so let's start with the first one. And I just moved the window on my side just to try to see if I can connect. Yes, which is amazing. So I said yes. I can move this thing there. It's connecting. It's not connected yet, so finger crossed. It should. We really need this demo to go. Ah, that's annoying. Okay, it doesn't seem to work. I don't know, too much noise. Yeah. There's a good lesson here, which is don't do Bluetooth demo in a room. Connected. Now it's gonna like go, take off, be uncomfortable, like in someone. No, take off, please. That's really. Now I'm gonna pick it up, and now it's gonna start. So I just wanna try to keep it close. Maybe it's again because of the screen. That's just weird. No, but we can try again. Sorry, guys. No, it's working pretty good. Yeah. Yeah. So the way this thing works is you can actually like move it around like this, and then land it without killing anyone. Okay. So this thing works, but the code is kind of very verbose. It still uses the proper API, so it's very long. And also, it's really hard to drive a drone using this control. I mean, this thing has been designed for a phone, but even on a phone, it's really hard to, you know, push those arrows around. So what I've done is I've wrote a second version of the script, which will hopefully work, that use the keyboard, because I'm more kind of a first-person shooter kind of person. So you can now drive the drone using the keyboard. So let's try. Okie doke. I'm gonna move it like I learn. I'm gonna move it here. I'm gonna connect. Okay. Okay. And now with the keyboard, it's easier to move it around. Yeah. Oh, wait. Yeah, too late. We'll follow up after the event. We can have like a. I'm just, you know, I'm not a drone driver. I'm really scared to like actually hit someone, so that's why I'm trying to. Okay. Okay. So this is really, it turned out to be really easy in the end to build, and it's basically just it. So there is a takeoff button that there's slightly difference, and this is why I'm so kind of grateful to all the people that tried to do this before me, is that this specific device, it as every Bluetooth Low Energy device, it exposes all of the services, but it does not like accept any kind of writing until you proceed with an authentication sequence. So the way it works is the device expects a specific sequence of byte to be sent to one of their characteristic before being, before start responding to actually actions like take off and land and move and things like that. So when you click the first button, what you have to do is actually send this sequence, which someone has found for me, thankfully, and then you can start interaction like take off and things like that. the on-flight interaction, so actually moving this thing around, is extremely simple. And the idea is uh, you have a function which keeps being called, and this function state the states of the drone at the current time. So in specifically, this function has like this sequence has like 4 variables, and those 4 variables are um, roll, pitch, yarn, and altitude. And what you can do is you can basically send values to those variables to change the state of the drone. So it fits really well for a keyboard control, because basically you can say every time the key is down, apply some like force to move it forward, and when the key is up, like remove the force. So it's super straightforward to implement, because basically it just said invoke the move is our Bluetooth characteristics. So pass the Bluetooth characteristic, the move sequence, which is this long sequence of instructions. But within that sequence, for example, is the W is pressed, apply 20, which is kind of a, you see an average speed. If the S is pressed, apply -20, and if D is pressed, apply 20, but on the roll side, so to make it roll. So it turned out to be really easy once again, I'm super thankful to the guy who did this first and actually like decoded all the messages that has to be sent. But it's super kind of exciting to be able to drive like a physical device from a Bluetooth when it works. So web Bluetooth is not all. There is another API which I haven't played yet. It's kind of on my list, maybe next year, I don't know. But this API is called WebUSB. This has been presented like at last year Google I/O, and it's really exciting. So the idea behind this web API is to allow USB devices to broadcast a URL, or like a URL, which contains the whole application to actually drive the device. So it's a way to bypass the needs to install drivers. I'm not talking about keyboards and mouses, more like either custom devices or very specific devices for which drivers are still required. So in that case, that scenario is completely changed, because the device itself can say, hey, you can find the application to drive me at this specific URL. And what you can then do using a Chrome browser for now is use a very a set of very low-level JavaScript API to actually write and read stuff on the specific USB port. So those two things together make driver useless and makes writing the application basically cross-platform. You have only to you only have to write it once, and it works everywhere, which is pretty good. So the quick like just taste of how this thing would work is you connect a WebUSB supporting device to your machine. The Chrome pickups this thing and asks the USB device for a manifest. The manifest itself contains a URL, like, I don't know, usethisdevice.com or whatever. And this URL, when clicked, load a page that now has the permission to access the device. And once the device has been accessed, you have like these are really high level, like you can print the product name and manufacturer name, but you also have very low level API to go down to the port and actually perform operations. This is especially useful if you're playing with Arduino, for example, because all these custom Arduino modules, they are really hard to, to kind of share, because they need drivers and things. In this case, you can make Arduino itself broadcast a URL that actually explains how to use your Arduino. And there's already an Arduino module that supports WebUSB. So this actually works. I just need to buy an Arduino, and yeah. So yeah, that's the next step. Unfortunately, the support is Chrome only, and the bad news is that this kind of orangish boxes means kind of we don't care from other browsers. So it's not even under consideration yet. It might be in the future. For now, there is Chrome support, and there is the last of the 4 boxes means there is like community excitement. But yeah, that's the point we are now. But it's a very new API, so yeah, finger crossed. I hope it will like take some more visibility in the future. Okay, so this is it. Sorry for the demo that didn't work. We're gonna try them again. Maybe even now, I don't know, we can do a second pass. But please vote my event. And thanks for the users that gave me the images for Flick. And yeah, let's take some questions and then we can do another round.